Welcome to the session on moments. The objectives for this session are to calculate the turning effect of a force applied to a rigid body. We have looked at movements involving particles but have ignored the effects of rotation. We will now explore modelling objects as rigid bodies, allowing us to examine the size of the object and where forces are applied. The moment of a force measures the turning effect of the force on a rigid body. So if we consider this diagram here, we have that the clockwise moment of F about the point P is equal to mod F times d, which is the perpendicular distance from P to the force F. And here, of course, the moment of the force F is acting about the point P. Sometimes the perpendicular distance is not given. Let's consider this diagram. Notice that the distance d isn't perpendicular to the force F. In this case, we need to calculate the perpendicular distance using trigonometry. And of course, if the hypotenuse, as shown, is equal to d, then the perpendicular distance is equal to d sine theta, given that the angle that is made between d and the force F is equal to theta. Therefore, we have that the clockwise moment of the force F about the point P is equal to mod F times d sine theta. Here force is measured in newtons and distance is measured in meters. So a moment is measured in Newton meters for this example. If the force is measured in newtons and the distance is measured in centimeters, then a moment will be measured in Newton centimeters. Let's now take a look at an example. Find the moment of the force about the point P as shown in the diagram towards the bottom of your screen. So let's solve this. We have that the moment of the force about the point P equals 9 newtons times 2 meters, which equals 18 Newton meters. And this, of course, is measured anti-clockwise. Now let's take a look at another example. We are required to find the moment of the force about the point P in the diagram. So first, let's calculate the perpendicular distance, which is equal to 6 sine 55 degrees, as shown. Therefore, the moment of the force F about the point P equals 19 newtons times 6 sine 55 degrees, which equals 93.4 Newton meters. And this is measured clockwise as shown. Let's take a look at another example. This time, two forces acting on a lamina are shown in the diagram. Find the moment of each of the forces about the point P. Notice that a 2D object whose thickness can be ignored is a lamina. Let's take a look at this force first. The moment on the 7N force about the point P is equal to 7 newtons times 2 meters, which equals 14 Newton meters. And this is measured anti-clockwise as shown. Now let's calculate the moment on the 10 Newton force about the point P. This equals 10 newtons times 1.5 sine 78 degrees, which equals 14.7 Newton meters. And this is measured clockwise. And so here's a summary of our results for this example. This brings us to the end of this session. If you have understood its contents, you should be able to calculate the turning effect of a force applied to a rigid body. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.